My name is Ketan. I'm the CEO of Union AI. I intermittent fast, so I have coffee black every morning, just like a shot of espresso with hot water in. Like another example that I actually typically give that I worked on as one of the first things is real-time traffic, right? So in ETAs, we were trying to use real-time traffic. ETAs are estimated time of arrival that Lyft would give when you want to get it right. And we were like, I think traffic will play a very, very critical role here. Because everywhere there's a lot of traffic, and that will change the ETAs dramatically, and we can bring down our RMSE and MAEs. And so let's try that out. And how do you prove it? Like, it kind of simulated a little bit. I tried it out, and it's like, maybe. So, but real-time traffic is a big challenge.
Yeah.
You have to get data real time, process it, analyze it. It was all code. Some of the code was in C++ because the routing engines were in C++. We were like loading things, and this takes like 6 months of effort to do this stuff, right? And that time we didn't even have Flight like thing. One of the reasons why Flight kind of works with any language is because of that stuff, right?
You're scarred in the beginning.
Yeah, and what it turns out is that thankfully we didn't invest in like real-time ML, as I've heard many times, because firstly, the speed at which you go causes a lot of aberrations, right? Like, think about this. There is one car that stops that we have a sample for. We think there's huge traffic jam, but potentially turns out that was just a stoplight, or it's just like, that person decided to stop for a little bit.
Drop it off there.
Or whatever,
friend.
right? Like,
Yeah.
And you don't want to change like the ETS. It's just dramatically fluctuate the ETS up and down. It doesn't matter. So you have to put a damper. You have to put like a bunch of other models. And it turns out the hourly predictions for a week are so good that the bias adjustment is what the traffic does only, like a little bit of addition, so that it improves the tail problems. It doesn't really cause a huge deviation in the center. So that's what we found. And you're like, okay, people are saying, well, let's do real time. And this is the most real time kind of a scenario that you can think of, like fraud, right? Like even in fraud, if one person does a fraud, you don't want immediately to react to it. Like saying that, all right, everybody else who's doing like everybody's known should be rejected. I'm like, no, dude, that guy was probably a one-off case, right? So you want to wait for a little bit, buffer it up, dampen it out. And then, so a 10-minute interval is what we found pretty good. So things like that. Like, you learn only when you try, and you don't know the real outcomes till you really put it in production.
Damn, I have to think about that. So I'm actually working on a project similar to that now. So maybe I'll be like, we don't need real-time ML here.